Yes.
Yeah, I think that is really easy.
All right. How many of you know what a polynomial is?
I remember learning that.
Has more than two.
It's actually poly means many, right? So we're looking at expressions that have one or more terms. And I've got that variable x that's still in there, okay? And so my x can have these different exponents on it. And there's a couple of rules you need to remember. My exponents on the variable have to be positive whole numbers. Other than that, I'm game for pretty much anything, and that tells me it's a polynomial. Pause while y'all write that. Some examples of some polynomials. Or actually, let me show you some things, and you tell me yes or no if it's a polynomial or not.
Do I have to write these, or can we just...
It's up to you. Tanner says no. Look at it and tell me what you think.
Write that too? Wait, which number are we talking about? All of them?
This is an example,
Yeah, but like which number within the thing?
Okay, so look, we're only talking about the exponents. Look at the first one. Yes or no, is it a polynomial?
Yes.
Why?
Because of the exponent.
All the exponents are positive whole numbers, right?
Yes.
You see that? So yes, number one is a polynomial. How about number two?
No.
Why?
Because it
That's
has a
not a whole
value.
number.
The exponent on the x here is a fraction. That's not a positive whole number. How about number three?
Yes.
Yes. Even though it looks like that in front, those are irrational numbers, it's not impacting the exponent at all. So yes, no,
Maybe so.
yes. This is no because of that. Yes or no?
Yeah.
All right, so let's get to the lesson today. Now that that's well, remember I told you we're skipping 2-2 and we're going to come back to it?
Yeah.
It's an analysis of polynomial functions. So what we'll do, I still wanted to explain what a polynomial function was, and we'll come back to it later on. That's the only piece you need from 2-2 to be able to do 2-3. All right, operations. When I talk about operations, I'm talking about...
So we record.
Huh?
We're
So we
gonna,
record.
so we're gonna
We're
operate
recording.
someone.
First, we're going to do addition. Now, think about this with me for just a minute. We're talking about addition of polynomial functions. You've actually done this before, just not with polynomials that are quite as big as what we're going to do here. So, for example, 3x to the third plus 2x squared minus 5x plus 1. Is that a polynomial?
Yeah.
Sure it is. I'm going to call that polynomial number 1. Polynomial number 2. Let's do...
So is the other side supposed to be, what was that line?
What line? That was the parenthesis. The pen just decided it was thinking. Shh. Minus 4x plus 7. Is that one a polynomial?
Yeah.
Yeah.
Yes, that one's a polynomial too. So we all agree that those are both polynomials, right?
Yeah.
Do you also agree that it doesn't matter the order that I added?
Yeah.
I can add any order. So if I need to add these, tell me what you're thinking. Tell me what's going through your head.
Add
Can I do
One half
similar,
x squared.
Similar. Y'all are saying it.
3 plus half.
Like terms. That's what I was looking for. We combine like terms. So if you're a little confused, maybe we need to go back. Let's define like terms to make sure we're all on the same page. What does it mean to be a like term? What has to be alike?
Everything.
So there's some different parts here. When I look, I've got a coefficient.
It has to have an X or the same.
This is a coefficient. Here's my base. And here's my exponent. So if they're like terms, give it to me in mathematical terms. What has to be the same for them to be like terms?
Exponent.
The exponent and the, not the coefficient, the base, or the variable, right? That makes them like terms,
So
do we all
2x
agree?
squared plus a half x squared.
All right, so look, because I want you to have this in your notes.
Is that right?
Like terms means same base, same exponent. You can have different coefficients, it does not matter, okay? So that's what like terms mean. So several of you said combine like terms. Well, if that's what like terms mean, what do you mean by combine like terms? What are you
Add them
combining?
together.
Adding what? The bases?
The number.
The bases and the
When you
exponent.
can.
The what number? Give it to me in mathematical terms. Yes, you do.
2x squared plus half.
Coefficient.
The coefficients. Okay?
So
Combining like terms. I know, I feel like I'm dragging it out of you. Combining like terms is combining coefficients of like terms, right? Are y'all following me?
Yes, ma'am.
Okay. I'll give y'all a second to copy that down before we move back up to. All right, so looking back up here at my problem, let's first identify which terms are like terms, and I'm going to do what I used to do when I taught Algebra 1. We're going to circle them in different shapes, okay, so you can see what's going on. This term has got an x and to the third. I'm going to circle it. Do you see any more x to the third terms?
No.
Nope, so it's by itself. How about, let's move to the next one. How about x squared terms? And I'm going to put a triangle. Yes. X squared. Right? How about just x?
yes.
Notice I'm taking the sign in front of it with it. How about constants? Or all matter shapes.
Should have did an oval.
I did a diamond. All right, so let's combine them. If I've got the cubes, I've just got the one that's the 3x squared, right? My circles. How about triangles?
Yes.
2 plus 1/2 is what?
2.5.
What is it? 5.
Oh.
5 over 2.
Why'd you do like that?
Yeah.
Because that's better than, we don't like mixed numbers.
Doesn't matter. You still kind of right if we have it like that.
I would prefer you to put it in improper fraction. Because when we start getting to some other stuff, you'll have to have it like that. How about squares?
And how did you get that?
What about squared? Negative 9x.
I mean, just like, yeah, squares like these shapes, square, not squares. Negative 9x. Juliana, what'd you say? How did I get what? Plugging it in.
Oh.
Okay. And then diamonds. Does that make sense to everybody what we did? This is just a combine like terms. The hardest part is finding the terms together and not overlooking anything. Yes?
Yes.
We okay with that?
We're gonna do one with subtraction.
Okay, so let's look at, do I need to do another addition example?
No.
I don't want to bore y'all to death.
Are we
Okay.
gonna divide and multiply?
No. Multiply today, yes. Divide is a 2-day process that will take us a while to do.
I mean, do we have to multiply today?
We'll start dividing tomorrow.
Are we subtracting today?
We're subtracting and multiplying today. Adding, subtracting, and multiplying. All right, so let's look at subtraction.
It's basically the same thing, right?
It is basically the same thing, but here's what you have to do. You have to remember whenever you're subtracting that you're subtracting everything in the second polynomial. And let me give you one, let me just throw you off a little bit here.
change the sign on the second one?
Yes, that's exactly what we're gonna do.
You kind of make it like addition, sort of.
I'm gonna put this, yes, you're exactly right. I'm gonna put this not in standard form for one of them now.
Grass grows, I don't like it.
As long as you keep up with what you have, it's okay. All right, so understand when you have this, I'm subtracting and let's even kick it up another notch.
We got 3 of them. We got a hard.
Let's make it like that so there's 3 of them, yes. Because I want you to see what that minus sign impacts, okay? If you look at it, what am I subtracting exactly?
X to the third minus 13. No, right there.
What's in this parenthesis, right? So everything in that parenthesis is being subtracted. So what I'm going to do, and this subtraction sign doesn't impact this polynomial, right? Do we all see that? So what I'm going to do, I know are y'all the same change kind of group? Did y'all learn that way? Okay. The first polynomial I'm going to keep the same.
When?
Sure?
That's one.
I'm going to change this and change everything in the polynomial that follows. But you have to change everything, okay? You can't just be one. So I'm going to change this one, and this one. Okay? Remember, it doesn't impact this polynomial. It only impacts the one that follows it. Does that make sense? So now I'm back to an addition problem. And with addition, all I have to do is combine what? Like terms. Get in the habit of starting with your biggest exponent because that's going to make it the easiest for you because that's going to put it in standard form in the end and it makes sure you don't miss anything. So it's the biggest exponent you see there. To the third, right? Negative x to the third. Are there any others?
No.
Any other 3's? No. So I got negative x to the third.
What?
How about powers of 2?
Yes.
9 plus 13 is what?
Plus 4.
Why did I think
22
Yeah.
plus 4?
26.
26. Did I go too fast for anybody? Combining 3 at a time? Remember, we're only combining the coefficients. The base and the exponent are staying the same. I know you think you know that, but when we start multiplying, it's going to start getting confusing. So when we add, leave the base and the exponent the same, only combine the coefficient. Okay? How about x's?
Plus 8x.
There's only 1 plus 8x. Constants.
negative 3
-3.
plus 4 plus negative 7.
Plus 4 is 1, minus 6 is
-5.
-5. So I'm going to put you a little note here that says, remember, when you add or subtract, we combine coefficients and leave the base and exponent. And I'll pause that and give y'all a second to. Let's multiply.
I feel like this is, never mind.
Before we actually multiply an entire polynomial by another polynomial, let's look at multiplying terms together first. If I asked you to multiply 2x to the third by 6x to the fifth, what do you do?
I put it in the box.
Multiplying.
You add 3 and 5.
You multiply the what? Somebody said it at the back. Multiply the coefficients, right?
And you add-
Remember, multiplication is commutative, right? I can do it in any order. And this is like 2 times x cubed, 6 times x to the fifth. So I could do the 2 and the 6 first, right? So I multiply the coefficients. Now, how would you do x cubed times x to the fifth?
When you add,
You add the exponents.
What's that?
So I multiply the coefficients and I add the exponents. Now remember, when I'm adding or subtracting, I'm leaving those exponents alone. When I'm multiplying, though, I'm combining them. Does that make sense? Okay. So what if I asked you to multiply 3x squared times this polynomial, 5x to the third minus 6x plus 4.
We have
Okay,
to
can we do this by ourselves?
What? Tell me what you're going to do before you do it.
Property.
you multiply
You
3x
distribute.
squared
Yep.
times, yeah.
Try it and see what you get. Try it and see what you get. It is a distribute problem, and I'm going to pause this and look. I take by the noise that y'all are done.
Yes, ma'am.
What do you get?
15x to the fifth.
So you multiplied the coefficients and got 15. You added the exponents and got 5. Everybody got 15x to the fifth for the first term?
Yes.
All right.
Negative 18x to the third. because
Good job, because there's an
one.
imaginary 1. Absolutely. 18x to the third.
Plus
And then
12x
12x to the third.
second.
Third. Oh, because there's no x.
There's no x. There's no x. Is anybody confused with that? Everybody okay? Okay then.
Oh, yes, it worked great.
No, I'm just fixing to kick it up a notch.
Ooh, you're not dividing, right?
No, we're not going to divide till tomorrow.
Are we gonna mix together
Polynomial
two of them?
multiplying.
I'm not going to start with a FOIL problem because I told y'all before I hate FOIL. I hate that method
Me too.
because it only works when it's two binomials, and I'd rather you know how to do it all the time. So we're going to do
I have a question.
yes.
Could you do the box thing for this?
No, because you're not. That's a 3. Because you're not factoring. We're kind of doing the opposite of factoring right now. We're multiplying out. All right. So when I have two polynomials like this, it was easy when there was just one term in front, right? Because it just distributed to everything. You know what you do now?
Couldn't you subtract 3 and 2 because they're both in the same side? X squared, x to the third, x.
No, because this I'm multiplying here in between.
But x to the second's on the same thing.
Can we just try this by ourselves?
But yeah, you can try while I'm. Juliana, what's happening is because I'm multiplying, if this was a plus sign here, yes, I could do that. But because there's a multiply sign, I'm going to have to go through the process of multiplying before I start combining like terms now. And I'll just tell you, some of you have started working it out, and that's perfectly fine. When you multiply polynomials, every term in the first polynomial has to distribute to the second polynomial. So before, where we just did 3x squared to everything, well now x squared has got to go to everything, 3x has got to go to everything, and negative 5 has got to go to everything. Does that make sense? All right, so as some of you work, I'm going to go ahead and walk the rest of us through this. If I do x squared times x cubed, I get
X to the fifth.
x to the fifth.
And then you're going to have to do it again.
X squared times negative x squared is what? Multiply the coefficients. 1 times negative 1 is,
X to the fourth.
yes, negative x to the fourth. Add those exponents together. How about x squared times 5? 5x squared. Now, I'm in the habit of, as I go through this so that I don't get confused, because when some of them get really long, it gets tedious, I'll go ahead and mark this one out because I've already used it. Now, if you don't want to do all that, you don't have to. It just helps me keep track of what I'm doing. Now I'm going to take the 3x to everything. What is 3x times x to the third?
X 3, 4.
Yes, 3x to the 4. What is 3x times negative x squared? Yes.
To the third.
To the third. Last one, 3x times 5.
15.
15x.
I got it.
I'm done with that one.
You have to put X.
Yes, thank you. One more. You got it?
Little box multiplication.
Oh, I don't know
That
that.
took is long.
All right, negative 5. Let's see if you come back to the same thing, Tanner. Negative 5 times x cubed is negative 5x
To the fourth one.
to the third. The 5 doesn't have an x on it.
Oh, yeah.
All right, negative 5 times, careful here, these are two negatives. Negative 5 times negative x squared is positive 5x squared. You don't know how I did it?
No, but I did it right.
Okay. Negative 5 times 5 is negative 25. So now I want to gather my like terms
You
up.
wouldn't have 5x squared, you would just have a 5 squared.
Where?
At the very end before.
Yes, yes. Which 5 squared is 25?
You put 5x squared.
That is this one times the middle.
That's so much harder to learn.
Oh.
So you just distribute everything to everything. All right, like terms. I've got a power of 5. How many 4s? All right, I got negative 1 and 3, which would give me what? 2?
Oh, we doing adding?
Yep, we're just combining like terms. How about powers of 3?
Yeah.
Negative 3 and negative 5?
Negative 8x to the third
How about powers of 2?
plus 2x squared
Plus 10x squared.
plus 15x minus 25.
Exactly. There's only one of those, so we can just write them. Does that make sense to everybody?
Very long though.
It is very long. I want to do one more with you that has this,
Oh,
Shamik, yes, we like doing these problems. What are you talking about?
no, we don't.
We don't. I like this guy.
Jason Tatum. You can't shoot, dude.
Easy.
You're doing it. Fuck.
Don't, if you know how to do this one, don't blurt it out. Multiply those then, since y'all know what you're doing. See what you get. And you probably already know this, but when I get students and I give them 3, they always want to start with the first one and start bouncing it to both pieces at the same time. You can't do that with multiplication. You need to take 2, multiply those out, and then multiply it to the third. So if you're working, keep working. I'm going to do this one as you work that one, and I won't talk and distract you. I'll just work it out so you can look up if you have a question.
Do you have the answer?
I always simplify here and then take to this third piece. I'll have the answer in about 30 seconds.
Oh, really? Already got it?
All right, as you start to get the answer, check yours against mine.
I got it right.
Did you? Good job.
I like
And tell me what we think. You like it? Good.
10 out of 10.
Good, 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 good. So what's going to happen as y'all finish this one up is in the next, well, the rest of this week, maybe the beginning of next week, we're going to be using these methods as we do some other things with our polynomials. So this is almost the background to get us to do what we're going to do with polynomials later on. But the good thing is it's easy. Does anybody have any questions? quickly, because this shows up on your homework as well, and I just want to make sure I tell you. If I give you something like this, and I say multiply that out,
You have to do x to the 4 to the 3 to the 4.
no. What do you have to do?
You have to distribute it all
X plus 3.
This, remember, if you ever see a plus or a minus inside the parentheses, you can't distribute that exponent. This means x plus 3 times x plus 3 times x plus 3 times x plus 3. I hear, oh no, yeah. Okay? All right, let me give you your assignment.